NASA's Jet Propulsion Laboratory presents the Von Karman Lecture, a series of talks by scientists and engineers who are exploring our planet, our solar system, and all that lies beyond.
Good evening, folks, wherever you may be. I am Brian White from JPL's Office of Communications and Education, and welcome to a special remote edition of our Von Karman series. And normally we greet you live from JPL's Von Karman Auditorium, hence the name, the Von Karman series. But here we are, reaching out to you from our respective homes. The show must go on. This evening we'll be speaking with the incomparable Tracy Drain on how to become a NASA engineer. What does an engineer do? They create, they build, they test, they solve problems, they develop, they plan, they ask questions, they collaborate, and they dream. I'd like to point out that Tracy's journey is not the only journey. There is not one set path to get to NASA, but she will be giving us some guideposts along the way, some helpful tips that helped her out on her journey. Right now, more than ever, we believe in the power of connection. If you are watching live on YouTube or Facebook, we want you to be involved in this discussion. Ask questions in the chat, and we will get to as many as we can during this show. And if you're not seeing the chat right now, refresh your browser, and if we run into any technical challenges, we'll roll with it. We hope you'll hang in there with us too. And finally, we ask that you stick around to the end. We're going to have a short little video about some of the other incredible things that our engineers are up to right now. But without further ado, let's meet our NASA engineer, Tracy Drain. Hi, Tracy.
Hey, Brian.
Thanks for joining us tonight. Let's just jump right into it. Don't necessarily need to give you an introduction because this is your path. How did you become a NASA engineer? I want to kind of check in with your early interest. I'm sure we have some students watching us here today.
Yeah, I hope that we do. I had a lot of early interest growing up, but a lot of them were shaped by my mom, who was very interested in science fiction. We watched Star Trek and Star Wars, Battlestar Galactica, all of those cool things. And that's part of the reason why I got interested in science fiction. She also, like every time there was a shuttle launch on, she would pause and watch it. We would sit there and watch it with her. Super exciting.
That's pretty, actually, if we could bring up image number 2, we got a great combination of that. Go to the NASA archives, you'll find all sorts of wonderful things. What do we have here, Tracy?
I love this picture. This is the cast of the original Star Trek standing next to the Space Shuttle Enterprise. So two of my very favorite things all mixed up together. Super cool.
Quick question. Was this what you wanted to do when you were young?
When I was really little, I was interested in a lot of things. I loved arguing with my older brother. If you're watching, hi, Tim. And so I thought for a while that I wanted to be a lawyer. I also loved digging in my grandmom's backyard and finding all sorts of weird things. So I thought I might like to be an archaeologist. I love flying. Maybe I want to be a pilot. But it was sometime around my junior year of high school when I started to think about, like, what am I going to study in college? What do I want to do? That I decided to go down a space track because I thought that that could keep me interested for my entire career.
So it was around high school that you really started to lean into this. Was it something that you thought you could do? Was it something that thought you could get into right away?
I wasn't too sure about that. Actually, I wanted to study astronomy, but I'm old enough that there was like no real internet back then, and I wasn't sure exactly what an astronomer would do. And so I decided that engineering, because I liked problem solving and doing puzzles, is something that I knew NASA would need. And I chose mechanical engineering because just in case I didn't get hired by NASA or one of the aerospace companies, I could still do a lot of things with a nice, broad mechanical engineering degree.
Okay. Let's get some of the public involved in this a little bit too. We've got 2 questions, one from Nathan on YouTube and one from Lexi. Nathan's asking, what are the best degrees and how high of a degree, bachelor's, master's, PhD for an engineering job, which I'm sure you could talk about. But another question was, is astrophysics also a good major to pursue if you want to become a NASA engineer?
Yes, so there's so many different degrees that you can choose if you want to be a NASA engineer. There's the obvious ones, mechanical, aerospace, electrical. There's lots of engineers that I knew who studied physics, who studied astrophysics. Some of them later got degrees in engineering. Not all of them did, because a lot of what you learn to do in school is problem solving. The basic engineering courses are great for that. And then when you get to work, that's when you really learn how to do the specific things that you need to do to build spacecraft or cars or wherever you end up working.
Okay. Where did you end up going to school?
I went to school at the University of Kentucky. I chose it because, well, it was not too far from home. I'm from Louisville, Kentucky. It was only about 70 miles away. That made the mom really happy. And it was a big enough school to have a lot of different majors. So if I changed my mind, I could do something else. I was in the marching band, and they had a huge, like 20-piece marching band, which was super exciting when I was that age. And I chose mechanical engineering there to start my path.
Can we bring up image 5? We've got a little bit of Tracy's path right here. It's kind of the Cliff's Note version of it. But you went to grad school at Kentucky, and then they're right there in the, well, let's talk about undergrad a little bit. Sorry, not grad school, undergrad a little bit. Were you successful right away? I know a lot of times people think that being a NASA engineer means you have to do this from when you're a really young age. You got to know it's the only thing you want, and you got to be a straight A student right away.
That's right. I talk to lots of college students, and the one thing that I want to make sure they take away is you don't have to be perfect the entire time. Undergrad is a great place to go learn some lessons. And because this was my first time away from home, there's lots of people their first time away from home, and you're trying to learn all the stuff and figure out how to be independent and eat right and get sleep and not go to too many parties. And when you're doing all of that at once, it can be easy to make some mistakes. And in my least favorite class that year was chemistry. It was a huge class, like one of those auditorium style classes with a professor way up front. If you sit in the back like I did, don't do that. And I did all the things wrong. It was a really early class. I stayed up late. I didn't read the material in advance all the time, like so many bad things. And as you would expect, I did not do well. As a matter of fact, I got a D in that first chemistry class, freshman first semester. I was really fortunate though, because I got an A in everything else. And so I hung on to my scholarship by like a gnat's eyelash. I had to keep a 3.3 GPA, and I think it was like 3.328. I just squeaked by. But then rather than like freaking out and deciding, well, engineering's not for me, I totally messed that one up. I learned that at my school, you could retake up to 3 classes, repeat. And if you retake up to 3 classes, if you get a good grade, you can drop the first one and it replaces it. So when you look at my college transcript, it looks like I got a 4.0 that first semester, but it didn't actually happen that way. So yeah, you don't have to be perfect straight out of the gate. You just got to figure out how to get back up and correct your mistakes, learn from them, and then don't do that again.
So you learned this lesson, it sounds like pretty early on in college. It took me a little longer to kind of learn some of those lessons. You're going through Kentucky, and then you had a pretty, our middle little part of that slide there is NASA Langley Research Center. How did that come about as an undergrad?
One of the things I loved, yeah, right. One of the things I loved about undergrad at UK, and I think this is true at lots of schools, right? They encourage engineering students, science students, lots of different students to do internships, co-ops while you're in school so that you can get a chance to see what the job is like, if you're going to like it. And I wandered into the co-op office beginning at the end of my sophomore year, I guess, like you do at UK back then. And I thought they would just hand me a list of options and say, here are the things, right? You're in Kentucky, you're going to build construction equipment or build printers or, the things that I saw around me all the time. But they asked me, so, hey, what do you want to do? And I'm like, well, I want to work for NASA. But what do you actually have? But they had a contact at NASA Langley, and she called me. We did a phone interview. And at the end of the interview, she's like, yeah, sounds great. Show up on May, whatever. And I'm like, you have got to be kidding. Sweet. And so that was my really first foot in the door working for NASA. And it was amazing, as you could imagine, just walking on the center and seeing the NASA signs everywhere and knowing they were working on wind tunnel testing in cool. It was just great.
So you're going to Langley, you're getting this hands-on thing because you asked. You took the initiative and you said, this is what I want to do. You were kind of joking, but it never hurts to ask, right? And you got to move forward with it. Are there any advice that you would give to people wanting a NASA internship, people who are going to be going on to a NASA internship? some fun lessons that you learned with that.
Absolutely. Exactly what you said. Like no one's going to just randomly drop opportunities in your lap if you don't ask for them, or at least it'll happen far less often. So even if you feel like a crazy person saying what you want, just go for it. All they can say is no, but they might say no, but do this and this and then, or they might say, let me introduce you to someone else who could get you there. So definitely ask for the things that you're interested in. And I think while you're interning, some of the obvious things are, do a good job, learn a lot while you're there, but also keep your head up and look around for the cool opportunities that you might find. Because one of my favorite things about that whole NASA internship experience, what didn't even happen on Langley, right? I was staying with some other interns and one of them walked into the living room and said, hey, I just found out that the space shuttle's launching in 18 hours. And if we pack up and leave like in an hour, we can make it. I'm like, what? Yes. So we call up image number 4, maybe?
Image number 3, actually.
Sure, image number 3. Thanks. So that's me and a couple of the interns that I went to NASA Langley with. And you can see way in the background, that little building looks small there, but that's actually the vehicle assembly building on the day that we were going to be watching a shuttle launch. And it was just magnificent that we got to go down there. And it was only because we seized that opportunity and hopped in a car and drove by. We were safe. Some of us stayed up all night and took turns, but it was just a great experience. And then when the shuttle actually launched, I don't know how many of the people watching have ever seen a shuttle launch, but it is crazy. You're not even that close to it, but just the overwhelming bass sound of the engines going just rocks through your whole body. It feels like it's launching right on top of you. It's pretty cool. I think that might be image number 4, where
can we weren't this close. Image 5, actually, or image 4? Image 4, yes, image 4.
No worries.
That one right there.
Yeah, just amazing. And for me to have been a little girl sitting with my mom in the living room watching the shuttle launches on TV, and then to be a NASA intern down at KSE watching one live was just such an incredible dream come true at such a young age too. It was phenomenal.
I love that idea. We're getting a question right now from Olivia, who's asking, and we can always refer her back to NASA's website, but any internships or camps available for 15-year-old aspiring engineers?
There are definitely camps available. I know about Space Camp, which I never got to go to. So jealous of my friends that I know who did. But there's Space Camp, which is for kids of all ages up to teens. I think they do it for adults also. I know that I used to see high school interns around the lab, but I'm not really sure we do that much anymore. I think it's mainly for students who are in college already. But you guys might know more about that, Brian.
Well, yeah, go to NASA or NASA JPL's website. You can go to educational opportunities, go to employment opportunities, and you can find those and ask questions, send emails all the time on those. So you get this great internship. You're working at NASA Langley, but you decide to go to grad school. If we can pull up image 5 again, back there on the end, you've got Georgia Tech.
That's right. I personally just did not feel ready to be unleashed on the world as a little baby engineer by the time I finished my undergrad degree. And I had heard, I didn't know how many things I would break, but I had heard that you got a chance if you do grad school, and especially if you do a thesis-based graduate degree, you get a chance to do a lot of independent work. You can choose what item you're going to research. You can work with your advisors in order to figure out how to do it. And it really, for me anyway, shaped my ability to just go out into the world and really be able to do all the things I wanted to do. So I chose Georgia Tech to do my master's degree in mechanical engineering and spent 2 years there doing that.
But that was something that you knew you needed to do. That wasn't a choice that was forced upon you. It wasn't something that NASA was like, hey, you got to come and get a graduate degree to work here, right?
That's exactly right. I know that even as a group supervisor, we've hired people with bachelor's degree, master's degree, PhDs. In the engineering realm, you can kind of be all over that map. I know that if you want to be a scientist at NASA, you certainly need your PhD to do that. It doesn't mean you can't be an intern as a scientist, but we typically hire scientists who have their PhD.
So you go to grad school, and if we can bring up image 6, this is where there was a question asked about what was your first job out of college? This is from Gaspar Lopez on Facebook. Is this it right here, where you are now today?
This is it. So after the end of my undergrad at University of Kentucky, I spent a summer in Louisville, my hometown, working at GE Appliances, but I knew I was going to grad school. And then near the end of my grad school degree, JPL came to a career fair. And I was actually, because of things that I had learned and read, I was actually looking for like the private industry booths. And I was about to walk right past the JPL booth, but the recruiter like reached out and poked me and was like, hey, aren't you going to stop? And I'm like, what? JPL, what is that? It's so embarrassing. And even having worked at Langley for 4 internship rotations, I had not heard of the Jet Propulsion Laboratory. You know, we tend to sometimes think of JPL as NASA as this monolithic thing and not realize there are all these different centers all across the country that all have their own little personalities. And so once the recruiter let me know that JPL was a center that put Pathfinder on Mars, I was like, okay, little antenna go up. What was that? Can we talk? And after talking with them for a while, leaving my resume, I was very fortunate. They forgave me for not knowing about JPL, and I got to come out to interview. Really fell in love with the campus. It's just beautiful here. It feels like a college campus. I pretty much drooled all over everybody they would let me talk to. And like, please give me a job. And I was very fortunate that they made me a job offer, and I took it. So I've been here since 2000.
And a great question that we got online from Diana Castro on YouTube. She asked if you've always been a systems engineer, or did you start with a different engineering group?
That is a great question. I was hired directly into the systems engineering division at the lab, which was interesting because I had never heard systems engineering together in a sentence before I was interviewing here. Yeah, this was a long time ago, back in 2000. And it was during my interviews on lab that what was then going to be my supervisor explained what the job was. The fact that a systems engineer needs to know a little bit about all these different areas and work with experts in order to figure out how a design is going to come together and then solve problems along the way. And it entails working with lots and lots of people, which I found very exciting. I'm such a people person. I love that systems engineering is a role that plays a lot in that arena instead of just being like locked in a room somewhere with a computer and signing a component.
I also want to make sure we get this out there. JPL.jobs is a good place to go and look for internships and look for jobs, particularly with JPL, where Tracy's talking about. Come work with Tracy someday. You started as a system engineer, but how did you? I love where exactly you got started, though. The kind of sandbox aspect of it.
Right. It took me a long time actually to understand why they let me do this as a brand new person. When I first got started, they paired me and a couple of other brand new engineers just out of college with a much more senior engineer and had us doing this thing called advanced studies. And the particular one we were working on was, okay, so pretend you want to have an all robotic outpost on Mars. Like, what would you do if money was no object and you could darken the skies with Delta IV heavies and land all this stuff on? What would you do? And we were like, well, maybe we could have these huge rovers that would build roads and these giant nuclear power plants that would beam power wirelessly around to all the other components and telecom antennas that would go around to let them all communicate. It was hilarious. And we had such a great time doing it. And I'm like, I don't know what I'm doing here because I just got my degree in mechanical engineering. But I now understand why they encourage very young people to do this kind of creative, out-of-the-box brainstorming thing, because even if those things weren't going to become real 5 years, 10 years, even 20 years, some of the things that we were playing with could eventually become the kernel of studies that are done down the road. And because we were too young to kind of know what the limits were, we pressed a little farther than you might normally do. And they paired us with a much more senior engineer so that we didn't get too crazy. But that was a lot of fun. They could almost have just not paid me and I would have just come to work every day because it was a blast.
Don't tell anybody that. Don't tell anybody.
That's too late now. It's fine.
Can we bring up image 7? I want to look at your path here, Tracy, because you didn't just stay in the sandbox. You really got to go all over.
That's right. I did. One of the things that's cool about being at the lab is that your next job can kind of come up in a variety of ways. And I was happily in the sandbox doing advanced studies, and I got a call from a gentleman who was about to start building up his project system engineering team on the Mars Reconnaissance Orbiter. And he says, Tracy, I bumped into you a while ago. You were asking me some questions about things, and you seem like a go-getter. I'm trying to get a couple of more junior engineers to pair with some of my senior engineers to round out my team. Do you want to come work on Mars Reconnaissance Orbiter? Like, Yes. I was too young even then to know you're not supposed to say yes until you talk to your supervisor, but I'm sure he talked to them later, they figured it out. And so I got to join the Mars Reconnaissance Orbiter team about 4 years before launch, half-time on the project system engineering team and half-time on the flight system engineering team. And maybe this is a good time to say a little more about what systems engineering is and the difference between those two things.
Great time, because we're getting questions from people online, in particular from Lexi Torres on YouTube asks, what is a systems engineer? So what exactly is a systems engineer? If you go to slide 8, image 8,
I forgot we had
you kind of take a look at that a little bit. Yes.
Perfect. Yeah, so I'll talk a little bit about how we design space missions here at the lab. And then on top of that, I'll layer and what is it that a systems engineer does. And I'll try not to spend like a whole hour on this slide because we could totally do that. So when you're trying to develop a mission, you start with scientists who are trying to decide what questions we want to answer. And then they have to decide, well, what data do I need to get those answers? Can I use an instrument from the Earth and point it at that thing? Can I do a flyby? Do I have to go and orbit a target? And so they work with mission designers to kind of work out a top level idea. And then we start to put together a concept for a spacecraft that would support the instruments and get them where they need to go. And then we have to test and do a bunch of analysis to make sure it's all going to work. And we strap it on the top of a rocket and cross our fingers and hope that works. And then launch it and off it goes. And then engineers and scientists monitor the data, make sure the spacecraft is okay until it gets where it's going, gets all the science or data, sends it back so that the scientists can analyze it and make awesome discoveries and advance the knowledge of mankind. Systems engineers are really cool in this whole program. That was a whole thing. So systems engineers at the spacecraft level are trying to think about all the things that need to work together. You have to have a thermal system, you need telecom, you need attitude control and power, all these things. And there will be subject matter experts in each of those areas who will know way more than you do about all of those things. But a systems engineer tries to look at it from the top level. How do we make sure things are working? We don't change something over here that has a bad impact over here, or we come up with a problem and you have all these different ways of solving it, but you can pick the way that's the best across the whole area. So that's the spacecraft or flight system engineering. And then a project engineering job is making sure that the spacecraft and the instruments and the ground data system and the mission design and navigation and the launch vehicle are all going to work together. And it's that same kind of thing. You're looking for decisions that you have to make so that it all works together. And because even though we're super smart here at NASA, sometimes we miss things because the things that we do are very complicated. And so problems crop up along the way, and you need systems engineers to pull in the right subject matter experts to talk over all the technical details and figure out how to solve them. And the same thing when you have a spacecraft in operations, because even though it's 300 million miles away, still sometimes things don't work quite right. And you have to figure out what to do. You have to get your data back and do a little mystery search to find what the problem is, and then either change the software or change the way you're commanding it so that it will still work. So systems engineering and the way we design a mission. Now you can all go do it.
There's a lot of stuff I think we can definitely unpack with what your answer with that. You're right. You could talk about that cycle over and over again. But two things I want to bring up that you brought up is, number one, you just admitted to everybody all over the world that you don't know everything. And from what you've told me, that's a great trait to have as a NASA engineer.
Yes, it is. And one of the things that I like to tell college students is sometimes when you're in class and you have a project and your professor's asking you questions, you feel this pressure, you have to have an answer. And if you don't have an answer, should I make something up? I got to look like I know what I'm talking about. But that so does not work when you're trying to build spacecraft and they have to work. If you don't know something, you really need to say, I don't know. And the rest of the engineers will say, yay, and then we'll go figure it out. Because if you just, there's this line, fake it till you make it. No. Fake it till you break it is what happens when you're trying to build spacecraft. And so it's really important to do things that you know and be aware of where the boundaries of your knowledge are and tell people when you don't know something, and then use that as a lever to go learn and figure out how things can move on from there.
Let's go back to some of the missions you worked on. If we can go to image 9 first, because you talked about a little bit before we got into the details of what is a systems engineer, but you went to Mars Reconnaissance Orbiter. What were some of the challenges that you've learned on your different missions throughout working at JPL? We're getting that question a lot right now, so I figure we'll just jump to that right away.
Well, a pretty obvious challenge. The way that I've described systems engineering, it's about knowing enough about all the things so that you can resolve issues working with people who are experts, right? Well, as a baby systems engineer, you feel like such a moron because the number of things you do not know feels literally infinite. And when you're responsible for something in a team of experienced engineers, then you have to ask so many questions and questions after question. And that's my number one lesson from when I first started on MRO. When you're new in any job, really, you feel like you shouldn't ask questions because it's going to waste the time of the experts. But what I found was, especially working on a very complicated spacecraft and you're trying to resolve a specific issue, there will be experts in that area, but also people who aren't experts in that area. And so when you're in a meeting and you ask a question and the expert explains, the other people around the room are learning things too. And even the people who know what the expert's going to say, there might be some nuance that comes out that is a little bit surprising. And then that leads you down a conversation path that might take you to a solution that might not otherwise have come up. So I learned that as a young systems engineer, that it actually was a good thing to be always asking questions. What does this do? Why does it work that way? Why are we doing it this way instead of that way? I mean, you have to ask the questions in a respectful way. You can't say, why are we doing it like that? But can you help me understand why this instead of that? Because clearly you're still learning while you're also trying to move things along. So that was a major lesson that I learned. I also learned that as a young systems engineer focusing on specific areas, sometimes you just don't have enough bandwidth, I'll say, to pay attention to a whole bunch of things that are going on. And I wound up doing a very similar job on missions downstream. And some people might think, well, why would you do the same kind of job on another mission? Won't that be boring? But the systems engineering job is so much about troubleshooting all these little issues that is very different on the next project. And you can use some of your knowledge from the past project on the next one, and then you have a little more bandwidth to pay more attention to other things that are going on and learn and contribute in more areas. I felt like, by the way, that spending 6 years on MRO, from 4 years before launch to 2 years in operations, was like getting my master's degree in systems engineering because I learned how we do the job here at JPL.
Very cool. I want to jump to image 10 now and talk about a different mission that you worked on, because a question that really does keep coming up, and you've talked to me before about challenges, because every mission has a challenge. And that's part of what makes, I hate to say it, your words, not mine, that's part of what makes a mission fun, are overcoming challenges.
Yes.
And you don't want it to be fraught with challenges. But can you tell us one or two stories about time on Juno and maybe a couple things that you as a system engineer and the team had to overcome?
I can. So one of the things that makes me laugh when people ask me about my time on Juno, I spent 2 years before launch and then 5 years in operations just getting to Jupiter, and then another year and a half or so once we got there. And people say, wow, 5 years in cruise, were you people just twiddling your thumbs and like sitting around, like playing, what were you doing? And there's so many things that the spacecraft had to do in order to make it all the way to Jupiter. And so many things went slightly differently than we expected that it was just exciting to be able to troubleshoot them. And one that I will remember is we only talked to the spacecraft once a week during one part of cruise that no, I won't tell you what we used to call it during one part of cruise. And on one Wednesday, we talked to the spacecraft and it was fine. And then we ended the session. The next Wednesday, we tried to talk to the spacecraft and it wasn't there. They had to look for it on the emergency frequency and they found it. It had rebooted and booted again and swapped to the backup computer. We were like, ooh, what just happened? So then we had to go start our little investigative search to figure out why did that happen and what can we do about it and is it a problem? And that led down some really interesting paths. Because we had swapped sides, we didn't have all the information from the primary side to figure out exactly what happened, but we could figure out what happened in the second boot and fix that so it wouldn't happen again. And then you would think, well, okay, so you figured it out mostly and the spacecraft is safe, so you're done with that, right? That was in 2014, I want to say, and it was like 2015 before we finally put the bows on that investigation. And then we had to decide, so you're a year out from orbit insertion. Are you going to stay on the backup computer or are you going to like tell the spacecraft to swap back? And we had some really fun philosophical conversations about that, deciding, do you swap away from working hardware because you want to be on the side that you did most of your ground testing on? Do you stay on side B and you're pretty sure side A is okay. And so that was exciting and challenging and fun.
I want to lean into that, what you're talking about with working in teams. How much of the job is sitting in meetings with other people who are very, very smart? Something that you've told me about, and I think is good because I've started doing it, is about taking notes in these meetings.
Yeah.
I could tell the story, but I like it. I think it's better when you tell the story. You NASA engineer, you.
Sure. Some ginormous percentage of my job is spent in meeting after meeting after meeting after meeting. And it's kind of hilarious because we're all working from home right now. And my husband works at the lab too, but he has a very different job from mine. He's like, are you in another meeting? Like, yes. And when this one ends, I have another one. Actually, today I have meetings at 8 and 9 and 10. I have a break at 11 and 12, and then 1 and 2 and 3, and a very short one at 4. Right? So it's a lot. And I know that some meetings can be, there's a perception that some meetings can be non-productive, that you're just sitting there and someone's presenting and half of the people are falling asleep. But the meetings that I'm in are not like that at all. We have very specific working issues we're trying to resolve, and they can be very interactive. Some of them are about status, and sometimes that status is surprising. And so that can be very interactive. So they're really, it's energizing meetings, working with a lot of people. And then the note-taking thing is kind of funny. I started taking a lot of notes when I was a much more junior engineer, just because there were so many things being said that I had no idea what they were. So I wanted to write them down so I could go find out later and then be more informed the next meeting that I had. And then later I determined I was taking notes just so that I could have something to refer back to. We have so much information in our jobs, and I would sometimes share those with other people. And at one point in my career, a very well-meaning person gave me a tip that I never would have thought of on my own. He was like, Tracy, so I know that you enjoy taking notes and you just do that for yourself. It's really kind of you to share them with other people, but just keep in mind, like, this is a very male-dominated industry, and some things you can do just make you seem more like you're just working on the administrative things and not like doing engineering things. So just keep that in mind and be careful. I'm like, wow, like, thank you so much. I never thought about that. Okay, I'll go off and think about that. And then I realized the flip side of that is that when I'm in a meeting with people working on a technical issue, we go through a whole bunch of stuff, we make decisions, and then we do actions. And then if no one sends out the notes of what happened, every single person in that meeting will have a slightly different understanding of what was done and what decisions were made and then what should be done next. And I realized that when I take the notes, and I take very good notes, and when I send them out, they have, here are the key highlights, right? Here's what we decided. Here are the actions, and here's who has to do it. And here's really critical things. And I send those out to people like I am controlling the history of what happened and setting the tone for the rest of the team, especially as I got into more leadership positions. And so I decided, well, that was a very well-meaning tip. I'm glad I thought about it. But now I'm going to keep up my whole note-taking thing because it's my way of making sure that things are getting done the way I think they should be done. Or at least if I send them out and someone says, that's not how I remember that at all, you can get that disconnect out into the open and figure it out so that it isn't a problem downstream.
I love that story. And I've started taking so many notes in my life now because I'm like, I want to make sure I have the history. I want to move on to kind of where people have been asking online, what you're working on now, and then any challenges that might come with that. And then I've got a question for you about that afterwards of maybe what's next, but let's focus on what you're working on right now.
Right now, I am the Deputy Project System Engineer for the Psyche mission. And I've had a lot of fun jobs, but it is one of the more fun jobs that I have had because this mission is so different from the ones that I've done before. I've done missions that what we consider more traditional chemical propulsion missions where you launch your spacecraft, it does a burn so that it's on the right trajectory to go somewhere, downstream does another one, right? The Psyche is a mission that's launching in 2022. It's going to go visit an asteroid that scientists think has a lot of metal in it. One of the hypotheses is maybe it used to be a little baby planet core. We're not sure. So we're taking some instruments to go and investigate and find out. And it uses solar electric propulsion. It's a low thrust mission. If you took like your hand and put a slice of bread on it, like the weight of that here on Earth in 1G is the amount of force that the engines produce. It's very, very tiny. but they are on and on and on and on. And you just have to burn really long time to get to build up, enough acceleration and get to where you're going. And the thing that's interesting about it is there's such a connection between that on-time thrusting and how much mass you take, because you need the mass as xenon, but you have to push it all as you're going, and the power that you have in order to have higher thrust coming out of your engine. And so those things play together in a way that's just super different from missions that I've been on before, and have given us some interesting challenges to try to work out at the project system level, working with mission system and the propulsion folks and guidance, navigation, and control. It's been super educational.
It sounds like you've had your dream job multiple times.
Yeah, I totally have.
What do you want to be when you grow up?
You know what's funny? Every time my supervisor asks me this, I'm like, I don't know. You're supposed to have a 5-year plan and a 10-year plan. I just don't know. And so for me, I've just been having a great time in my career. I was on MRO. I left MRO and spent a couple of years working on the Kepler mission. I left Kepler and spent 9 years of my life on Juno mission doing project system and flight system engineering again. And because the missions are so different and the things that I focus on are so different, from requirements development to running tests, analyzing data to troubleshooting anomalies, it's crazy amounts of fun. I just really enjoy it. And so I'd never been able to think, well, someday I want to be the lab director. I might, or someday I want to be project manager, or those things. I'm just super happy enjoying what I'm doing. And it's interesting because my plan when I joined Psyche 4 years before launch was to see that whole development cycle, stick around for operations. It's going to take about 3.5 years for the spacecraft to get to the asteroid and a couple of years to do the mission. I just wanted to do that whole cradle to grave thing. It's a really cool mission. But the opportunity has come up for me to go and now be the lead flight system engineer on the Europa Clipper mission. And I really couldn't turn away from that one. So I'm super excited for that. It's a brand new mission for me. The team has been working on it for a long time now, but now I get to help see that mission to the launch pad, get back near Jupiter, but to go study Europa, which is a fascinating place to learn more about, because the scientists are pretty sure that there is a lot of liquid water beneath the thick shell of ice on that moon, and maybe all the ingredients where life could arise. So I'm super, super excited to get to be a part of that whole mission.
One of the things I appreciate just talking with you is how much joy and vibrancy you bring to everything. I want to, if we can bring up image 11, this is something that I've always noticed about you, is that you still are a kid at heart. And I've seen you make both of those faces before. That passion and joy that you bring into it. You seem excited to go to work every day.
Absolutely. One of the other things that I like to tell students is, just because you grow up to be an engineer or a scientist doesn't mean you have to be like this super serious stick in the mud person all the time. And I love the fact that most of the people that I work with on lab also really enjoy what they're doing. And so before meetings start, we're joking around with each other, talking about the things that we've done, what our hobbies are. Like it just makes your life much more worth living if you can enjoy it as you go. And I do enjoy going to work every day. I mean, not every day, there are those days, but most of the days. And as a whole, I'm super excited about the kind of work that we're doing. I mean, how many people get to go help develop things that are going to get launched off this planet to go learn other things about our solar system? It's kind of amazing that I got to grow up and have this as my job. Maybe I do know what I want to be when I grow up. This is it right here.
This is it. You're doing it right now. And I love the bookend of your career. Not that there's an end to your career right now, but if we bring up image 12, how you got started and really where you can be today, I mean, that's Uhura right there. That's you and Uhura.
It is. For those of you who don't recognize her, that is Nichelle Nichols, who was the original Uhura on Star Trek. And she came to visit the lab a few years ago. And fortunately for me, I was one of the people who got to go and meet her and tell her how important she was to help set me on the trajectory that I'm on now, because one of the reasons that my mom loves Star Trek is that Uhura looked like my mom's older sister. And so they would rush home from school to watch the show. And that's how she got hooked on science fiction and why she dragged me along with her. So I don't know what my life would have turned out like if mom wasn't watching that show and wasn't such a sci-fi buff. So it was my very great pleasure to meet her and tell her thanks and hello from my little mama.
I want to open it up to some questions online that we're getting right now. Brandon Lee on YouTube asks, what extracurricular activities should you do to prepare to be a NASA engineer?
That's a great question. There are a lot of things that you could do to help prepare to be a NASA engineer while you're in school. It's so great right now that it's really inexpensive to get those computer parts. You could build your own little rovers. Have you heard of Arduinos, right? You have an opportunity to go and explore some of those things and learn those problem-solving skills on your own. When you're in high school now or college, you can join robotics groups. There are colleges now that build nano satellites and sounding rockets, and the experience that you can get doing those things directly applies to what you need as an engineer working at NASA. It's also great if you want to go do internships like I was able to do. And if you try to get involved in those things and you can't, don't freak out. There's plenty of other things you can do that are also applicable to being an engineer. One of the things that we like for systems engineers to show is a diversity of interest, not someone who's just doing engineering, but people who are on sports teams learn a lot about teamwork. People who are musicians, lots about teamwork. People who do art, a lot about creativity and thinking outside the box. So you don't have to think that you must stick to engineering science activities. Do some of those other things too, so that you can be a well-rounded person. Don't kill yourself though, get some sleep. Don't try to do too many things at once.
Well, that's a good segue question to James T on YouTube, kind of extracurriculars, but then, and I imagine this is just your opinion, this is not the official opinion of NASA, but is there more pressure to graduate from a traditional engineering powerhouse, MIT, Caltech, Georgia Tech, than it is to have research experience and a high GPA? Thanks for the question.
Yeah, definitely my opinion and not the opinion of NASA, but I do think that there is pressure there, and whether that's pressure that's coming from the internet, from the culture, from what you hear from other people, whether it's, where companies go and do their recruiting, right? If you go to Georgia Tech, you'll see ginormous recruiting from all sorts of places around industry. If you go to a very small college that might not have as high of a profile, maybe they don't have a career fair that's that big. But one of the things that I think is great about the world today is the internet gives people much more access to information, much more ability to get your resume and the things that you're doing out in front of people. One of the things that you always want to do is network. You might feel like you can't if you're in some small college town, but if you can just get online, search for some people, shoot people a cold email. Hey, I'm a student studying blah, blah, blah. Can you just talk to me for half an hour and give me some career advice? You'd be surprised the number of people who will say yes to that. I talk to students frequently just to give them some tips and tricks that might seem obvious to people who have been around the block for 20 years, but certainly isn't obvious to someone who's just starting out. Don't everybody call me because I don't have that kind of time. But I do like to do that once a month or so to try to help out students. And when I can't, then I might try to hook them up with other people that I know just to give them some insight. But yeah, lots of things you can do.
Well, that was a great addition to what Becca H asked, is how do you find time for mentoring while doing all this systems engineering?
You guys are great with the questions today. For me, that one is tough because especially when we're in times where we have major reviews coming up or major launches coming up, you have to figure out how to compress some of the other things in your life so you can get all the work done and not be up for 24 hours a day every day. And so I might do a little less mentoring during those times. But for me, I just really enjoy seeing people succeed. And I had so many people help me in my career that I just like to give back and to sort of pay that forward. And so if it means that I will have a mentoring conversation during lunchtime, I've done that, quite a bit with people that I'm mentoring right now. Hi, Christina. And if I have to do it at 5 p.m. or on a Saturday, I will try to get in an hour here and there on a regular basis to try to help out people like that.
So we'll do one last question and then we'll move on. There are a lot of questions coming through and they've been amazing questions. But one that we are getting a lot it's kind of broad, but I think knowing you'll be very specific about it. What do you think is the best way to inspire the next generation? And is there any advice that the one piece of advice from this point forward, you would say, this is what helped me. I hope take this, and if it works for you, it works. And if it doesn't, I'm sorry.
I think the best thing the thing that I like to do, let's say it that way, to inspire the next generation is to just do what I enjoy, so that when I'm talking about it, like you said, you can tell that it's something that I'm excited about and I love doing, instead of saying engineering is really important and you should do it because we really have to have refrigerators and cell phones. Like, those things are great, but it's lovely when you can feel fired up about the thing that you're doing. The second thing I will say, which is going to sound super contradictory to that first thing, is I know that students hear coming at them all the time, like, find your passion and do what you're passionate about. But the next thought is, okay, how do I do that? Like, how do I know what I'm passionate about, and how do I go about doing it? There's, I wish that someone had told me this, which is, you don't have to get it right the first time. You really don't. There's so much pressure on students to pick a career that they're going to be satisfied with forever, because if they don't, they will have wasted X number of years and X number of dollars in loans and, end of the world kind of situation, right? But there are people that I know who chose a career path, started down that career path, 10 years into it, said, this isn't working for me, I want to do something else, and figured out how to go back to school while working and try something else. And now they are satisfied with what they're doing. So I think you just have to, just don't stress. Yes, you have to pick something, but try it and see how it goes. And if it's not great 2 months in, it's only been 2 months, keep going for a while, and know that you can change your mind, even though it might feel like the walls are closing in when you want to choose to do that.
What I like talking about you is, I'm not an engineer, but I feel like a lot of the advice that you give is good for no matter what you're doing. And stick around with us for a second, but we want to just let everybody know, before we leave you tonight, we're going to step in on John Krasinski's territory and talk about some good news. On April 1st, NASA launched an agency-wide call for ideas for how the agency can leverage its expertise and capabilities to help the nation with this unprecedented crisis. In just 2 weeks, 250 ideas from NASA's scientists, engineers, everybody were submitted into this. Now, here's what some JPL engineers decided to do, and we're going to show you a short little video.
We are designing an easy and rapidly mass manufacturable ventilator device, and it is a crazy project.
This crisis is unprecedented in our lives, and requires precedented action.
I'm so amped up. I mean, the adrenaline rush, it's exciting, but it's exhausting. And I think we all just want to do everything we can to try to help.
You ready?
Yeah. Oh, very cool. That's awesome.
I would say the biggest personal challenges that I have myself is I don't have time to sleep.
I think that what JPL brings to the table is extraordinary talent. It also brings to the table tremendous innovation. The third thing it brings to the table is tremendous focus. The other thing that I felt, I see it in our team, and that is a call to duty. I have this talent, I'm an engineer or a scientist, I can do something.
We have the potential to save human lives, people that we might know, our neighbors, our families. And that intensity, amazing. It's amazing. And as stressful as this has been for everybody in the last couple of weeks, not one of us can stop.
Vital was recently authorized by the FDA. It is designed to treat patients with milder symptoms, thereby keeping the nation's limited supply of traditional ventilators available for patients with more severe COVID symptoms. The device can be built faster, maintained more easily, and with far fewer parts than a traditional ventilator, thus making it more economical to produce. The designs for licensing these are royalty-free during this time. This is just one of the few NASA responses to our current world. So what do engineers do? They solve problems, they collaborate, they help. I want to thank Tracy Drain for sharing her time with us this evening. Thank you so much, Tracy. I learned a lot. I hope everybody watching really learned something too.
My pleasure, Brian.
I hope everybody joins us next month when my colleague Preston Dykes will be hosting Making a Mars Rover. Thank you for joining us this evening. Thank you to Tracy Drain. Please stay safe, stay kind, and we'll see you next month. Thank you, everybody.